Hi everyone, I hope everything's going well for you. For today's lecture, we're going to go through Chapter 3. This chapter discusses the composition of GDP, demand for goods, and determinants of equilibrium output. We're also going to be talking about the relationships between production, income, and demand. In fact, production, income, and demand are all linked. A change in demand would affect production, a change in production would affect income, and in turn, a change in income would affect demand for goods. Now suppose that you earn some extra money. What would you do with it? What can you do with it? Say you decide to save a part of it and consume a part of it. So what does the part that you save become? And what does the part that you spend become? So the part that you save becomes a part of total savings in an economy, and the part that you decide to consume becomes a part of total consumption in the economy. What will the person whose income it becomes do with it? That person in turn will spend it on other goods and services. And this keeps repeating as money changes hands, thus amplifying the total size of that increase in income. This effect is called the multiplier effect. Now, instead of you spending the money, suppose that the government does. Does the same process repeat? Yes. If the government buys something, in turn the receiver is going to use that money to spend on other things. And this keeps repeating, thus increasing incomes infinitely as money changes hands. Recall the composition of GDP from your Principles of Macroeconomics class. Consumption is the largest component of GDP, accounting for about 68% of GDP in 2018. It represents goods and services purchased by consumers. Then you have investment, which includes firms' purchases of new plants and equipment, as well as household purchases of new houses or new apartments. Followed by government spending, which includes goods and services purchased by federal, state, or local governments. However, this does not include any government transfer programs like Medicare or Social Security or payments on government debt. And then you have net exports, which is the difference between exports and imports. This is also referred to as the trade balance. And then finally, you have inventory investment, which includes goods produced but not sold in a given year. Now look at Z. Z is the equation for demand for goods and services for an economy. Z is equals consumption plus investment plus government spending plus export minus imports. This equation is just an identity that says that total demand for goods and services must equal to what we spend on those goods and services. Now notice that inventory's investment is a part of GDP but not included in Z. And that is because inventories were not sold and hence not a part of aggregate demand for that period. Now before we proceed, we need to make some assumptions. First, assume that there is only one homogeneous good that firms can produce. It can be bought by consumers for consumption, it can be produced by firms, or it can be used by the government. Second, we need to assume that in the short run, firms are willing to supply any amount of good at a given price level P. Third, we assume that residents of this economy strictly prefer to buy local, as do residents of any other economy in the world, which means that X minus M does not exist in this model because this is a closed economy. Now let's look at the determinants of consumption. Think about what factors are important to you when you were making a consumption decision. Like what factors are important for you when you want to buy a new computer or a new watch. One of the major determinants of consumption include disposable income. This disposable income is the income left over after taxes are deducted, so Y minus T. These taxes include transfer programs such as Social Security, which are treated as a negative tax. So from now onwards, we are going to assume that consumption is a function of disposable income. So this equation here basically says that your consumption is a function of disposable income YD. Now let's assume that this is our consumption function, which follows a simple linear form. So our consumption is equal C0 plus C1 times disposable income YD. So this C0 is basically our subsistence level consumption, which is the level of consumption even if our disposable income was zero. C1 here represents marginal propensity to consume, which shows how much consumption increases if disposable income increases by 1 unit or $1. Our marginal propensity to consume C1 falls between 0 and 1. Graphing the linear consumption function with consumption in the vertical axis and disposable income in the horizontal axis would yield the line graph in the figure, where C0 here in this equation is the intercept of this line here at 2, and C1 here is the slope of this line. Recall the difference between exogenous and endogenous variables. For now, we will assume that investment is exogenous, that is, it does not depend on any other variables in the model, unlike consumption, which depends on disposable income, and hence it is endogenous. In addition, we will also assume that government spending as well as taxes are exogenous. An equilibrium in the goods market occurs when production Y is equal to demand for goods Z. Notice that income and production are both referred to as Y. Why do you think that is? That is because income is received by selling goods and services. Hence, production or national output is equal to national income. Using the demand for goods equation, which is Y equals C plus I plus G, and substituting in for the consumption function, we get Y equals C0 plus C1 times Y minus T, which is your consumption function, plus I bar investment plus G government spending. The textbook solves the model in 3 ways. First, algebraically. This is to ensure that logically our solutions make sense. Second, graphically, to help build intuition. And third, using words by explaining the results. Recall the equation that we had in the last slide. The next step is to distribute C1 through the parentheses. Next, we need to move all the y's to the left side. So we are going to move C1y to the left side, and here by pulling out y, we have 1 minus c times y, and then we rearrange the right hand side of this equation. Since our goal here is to determine equilibrium output, we need to divide both sides of this equation by 1 minus C1 to solve for y and get this equation. Once we have solved for y, we need to think about what each part of this equation means. So this part of the equation actually represents autonomous spending, because that is the part of the demand for goods that does not depend on output. Now recall that this C1 is actually your marginal propensity to consume. And because C1 is between 0 and 1, this entire number, this entire equation here creates a number that is greater than 1. And because it creates a number that is greater than 1, it amplifies the changes in autonomous spending. And that is why this is called the multiplier, because it multiplies the changes in autonomous spending. Sometimes the effect that this multiplier creates is also called the multiplier effect. When discussing fiscal policy, a natural question is to ask what form it should take. Should we use more of government spending or more of taxes to make changes in the economy? Should we increase government spending by more, or should we decrease taxes by more? In our model, what causes Y to increase more? Increasing government spending by $1 or decreasing taxes by $1? Let's see. Recall the equilibrium output that we solved for in the last slide. Now our goal is to find out the effect of increasing government spending by $1 on equilibrium output. And the simplest way of doing that is to replace this G by $1 and put everything else equals 0. So G would be $1 and all of this would be equal 0. And once we do that, we solve for y when G is equals 1 and all other autonomous spending is equals 0. We get y equals 1 over 1 minus C1, which is, by increasing G by $1, equilibrium output increases by the multiplier effect. Now if someone was to ask you, what would be the effect of increasing government spending by $100? Then you would just multiply this by 100. And you would get the effect of increasing G by $100 on equilibrium output. Similarly, to find out the effect of decreasing taxes by $1 on output, we can insert T equals -1 and all other autonomous spending equals 0 and solve for y. And here we find y equals C1 over 1 minus C1, which is actually less than this effect. And this is less than the effect of government spending because C1 falls between 0 and 1. This tells us that in our model, increasing government spending by $1 has a greater impact on increasing output than decreasing taxes by $1. Now the question may ask you to find out the effect of a simple increase in government spending or a decrease in taxes without mentioning how many dollars it increases by. If the question asks you something like that, then it's easier to find out a derivative. So using the equilibrium output, we can basically find out the effect of a change in government spending on equilibrium output by differentiating y with respect to G. And we get that the derivative is equals 1 over 1 minus C1, which is equal to the multiplier effect. Similarly, we can find out the effect of a change in taxes on output by differentiating y with respect to t, and we get C1 over 1 minus C1. Since differentiating gives the change in the numerator for a 1 unit change in the denominator, the derivatives in this slide are the same as the increase in output in the last slide. The government always wants to avoid budget deficits. A budget deficit occurs when tax revenue is less than government spending. A balanced budget is when taxes are equal to government spending, that is T is equals G. A balanced budget increase is when taxes are increased and government spending is increased by the same degree. So what effect would a balanced budget increase have on equilibrium output in our model? We already found that a $1 increase in government spending increases output by 1 over 1 minus C1. Again, we already found that a $1 decrease in taxes leads to an increase in output by C1 over 1 minus C1. So we can safely infer that the effect of a $1 increase in taxes will lead to a decrease in output of C1 over 1 minus C1. In order to achieve a balanced budget, we want to increase taxes and increase government spending by the same amount. And hence to do that, we will add these two effects together to get the total effect of a balanced budget increase in spending, which will be equals 1. This means that a balanced budget increase will have no impact on equilibrium output in our model because taxes were increased and government spending was increased by the same degree. This graph shows the equilibrium in the goods market. In the graph, the 45-degree line represents production and the thick line, which looks like the consumption curve, represents demand. The equilibrium is when both lines intersect and the slope of the line is C1. The intercept of this line here represents autonomous spending. Okay, so we're still looking at the goods market, okay, graphically. So we remember that this is the level of autonomous spending that we have, okay? So now we're going to imagine a case in which the autonomous spending increases to this level, okay? So this was our initial equilibrium at this point. When autonomous spending increases, demand and production increases as well, okay? And when production increases, incomes of people increase as well. And when income increases, again, demand increases and then production increases. And then again, because production increases, income increases. And then because income increases, demand for goods increase, and then production increases. And this continues till we reach this new equilibrium point. So, following an increase in autonomous spending, there is an increase in income and an increase in production. Now, initially the increase in demand leads to an equal increase in production equal to the autonomous spending, which leads to an equal increase in income. But this increase in income leads to an increase in demand of the marginal propensity to consume times the autonomous spending, which leads to the same increase in production. This repeats infinitely and sums up to a geometric series as shown below. This geometric series simplifies to 1 over 1 minus C1, which is also the multiplier. So, a 3 billion increase in autonomous spending or autonomous consumption leads to a 3 billion times the multiplier increase in equilibrium output. Remember, towards the beginning of the lecture, I said all these three variables are linked. Your production, the demand, and the income are all linked. So your production depends on demand, your demand depends on income, which also must be equal to your production. As was also visible from the graph, a change in demand or an increase in demand increases production, an increase in production increases income, an increase in income again increases demand, an increase in demand again increases production and income, and it goes on. It's like a cycle. At the end of every cycle, output increases. This leads to a cumulative change in output more than the initial change in autonomous spending, and this is your multiplier effect. Now let's look at an example from the goods market, and we will discuss why I call it the shock absorber version. The consumption function looks similar to what we've seen before, and government spending is still exogenous. However, investment and taxes are endogenous. That is, they are endogenously determined within the model. Here, T0 is the level of taxes the government needs to pay for bare minimum level of services, and T1 here is the tax rate. I0 is the minimum level of investment needed to keep the economy running, and I1 here is the amount invested for every $1 of output. This I1 here is also called the propensity to invest for each additional dollar in output. To solve for the equilibrium output here, we substitute for the tax function and the investment function into the demand for goods equals output equation here. In order to solve for y in this equation, we need to separate the parts without y and separate the parts with y. After that, we need to rearrange the equation in such a way so that all the terms with y in them are on the left side. And then finally, divide this term on both sides to solve for this equilibrium y for this particular model. Okay, so again, this is the equilibrium output that we found out from this model, and this is the multiplier associated with the model. Okay. Now, the first thing that we have to ensure is that the multiplier is positive and defined. And in order to do that, we have to assume that this part of the multiplier is less than 1. So this part of the multiplier is less than 1. And then this part of the equilibrium output is autonomous spending. It looks a little different from the one that we had done before. Now, what is the effect on the multiplier of increasing investment rate on the denominator? Increasing the investment rate I1 makes the denominator smaller and the multiplier larger, leading to an increase in the multiplier effect. And it makes sense, right? Increase in the investment rate will amplify the increase in output. Now, what happens if the tax rate T1 increases? If the tax rate T1 increases, that makes the denominator larger, which decreases the size of the multiplier and hence leads to a decrease in the multiplier effect. And that would make sense, right? Increasing tax rate, decreasing economic activities. Now recall the tax function, which is tax burden T equals T0 plus T1 times Y income. That total tax burden T increases when Y increases and falls when Y falls. This gives it the property of being an automatic stabilizer because it will fall in recessions and rise in expansions, which will dampen the fluctuations in GDP. Therefore, when there is a negative shock to autonomous spending, automatic stabilizers will control the amplification of that shock. That is why I call this the shock absorber effect. Now, we've been talking about the marginal propensity to consume a lot in this chapter, but how would we calculate or measure the marginal propensity to consume for an economy? One way would be to plot the changes in consumption versus the changes in disposable income. Another way would be by using econometrics. Now recall from your principles of macroeconomics class that MPC, your marginal propensity to consume, is equals change in consumption over change in disposable income. So if we have data for many years, we need to define our variables. So our change in consumption at time t is equals consumption at time t minus consumption in time t minus 1. And the second variable that we will need is your change in disposable income at time t, which is equals disposable income at time t minus disposable income at time t minus 1. After calculating change in consumption at time t and disposable income at time t for all years, we can find the MPC, the marginal propensity to consume, using econometrics. We can estimate the following equation by running ordinary least square regression. Here, change in consumption at time t is equals alpha plus beta times change in disposable income at time t plus epsilon t. We're basically estimating the correlation between change in income and change in disposable income. In this equation, this beta is your marginal propensity to consume. We can additionally plot the data with change in consumption in the vertical axis and change in disposable income in the horizontal axis. And as you can see, the data exhibits a positive relationship between change in consumption and change in disposable income, meaning that the marginal propensity to consume is positive. And as Y increases, C also increases. So here, for years 1960 to 2016, your MPC is calculated as 0.62. Because your MPC is less than 1, this means that changes in income levels lead to proportionately smaller changes in consumption of a particular good. Until now, most of our discussion has been about how output instantaneously adjusts to changes in demand. However, it may take time to change the level of production. That is why we must think about what the dynamics of adjustment are. Firms make their production decisions every quarter and hence cannot instantaneously change production. If demand is higher than production, firms draw goods from their inventories. If demand is lower than production, firms accumulate inventories. Now, if consumers decide to spend more, demand in the economy increases, but production is still fixed at the beginning of the quarter, so it can't really change. Therefore, income is unchanged. Since demand increases and production cannot increase right away, inventories fall to compensate for the high demand. This serves as a signal for firms to increase production in the next quarter. If demand or purchases is less than production, this serves as a signal for firms to produce lesser in the next quarter. This model can also be presented in a different but equivalent way. Now think about the types of investment there are in the economy. We have private savings, which is disposable income minus consumption. And then we have public savings, which is saved by the government, which is taxes minus government spending. So, private savings is equals disposable income minus consumption, and then disposable income is actually income minus taxes. So we can incorporate y minus t in this equation. Now let's return to the equilibrium in the goods market. We have this equation y equals c plus I plus g. Now we have to bring c to the left side and then subtract taxes t from both sides. And if we do that, we will get this equation. Now notice that this y minus t minus c, which is your disposable income minus consumption, is actually your private savings. So we have private savings equals investment plus government spending minus taxes. Now we can rearrange this equation to look like this. So your investment is basically your private savings plus your public savings. We can solve the model in a different path as well. Now let's take our private savings again and insert the consumption function into this equation. We can rearrange this to pull the y minus t's together. And finally, we get this savings equals minus C0 plus 1 minus C1 times y minus t equation, where this C0 is the subsistence level of consumption, and increases in C0 leads to decreases in saving, because this is a minus. Since C1 is the marginal propensity to consume, we can safely say that 1 minus C1 represents the marginal propensity to save. In equilibrium, investment equals savings, so we can write this equation as investment equals private savings plus public savings. And thus we can solve for equilibrium income. Now suppose consumers want to save more by lowering their subsistence level of consumption, C0. If we look at our equilibrium conditions, we can see that a fall in consumption would lead to a fall in output. But what about savings? Well, there are two cases. First, a decrease in subsistence consumption leads to a decrease in output. And according to this equation, a decrease in output would decrease savings. Second, a decrease in subsistence consumption also increases savings here because this sign here is negative. Therefore, the result is ambiguous because a decrease in subsistence consumption to save more leads to both increasing in savings and decrease in savings. Hence, the result is ambiguous. But we can look at the equilibrium condition here to determine the net effect. We have assumed investment to be fixed. If investment is fixed, savings must not change either. Therefore, trying to save more actually decreases output but leads to savings being unchanged. This is the paradox of savings or the paradox of thrift. Now let's look at a few models that will help you prepare for the exam. So let's look at a simple model. So this simple model has taxes, investment, and government spending fixed. And the equilibrium in this model is given by this equation. If we wanted to calculate the change in y when an exogenous variable changes, then this is how we would do it. A change in y equation. Recall that these three variables are fixed, which means their changes would all be equals 0. The resulting equation here would be your change in y. Now let's look at a somewhat less simple model. In this model, taxes are exogenous, government spending is exogenous, but the only change is that investment here is endogenous. Evidently, we have an equilibrium output that looks a little different from that of the last model. For the exam, you should learn how to solve for these equilibriums by your own. Now the equation for the change in y would be given by this equation, where this and this, your change in tax and change in government spending, would be equal to 0 because these two are fixed. Now let's look at the least simple model, where tax and investment are endogenously determined within the model. And in this model, the equilibrium would be given by this equation, which again you should learn how to do on your own and find out the equilibrium equation. The equation for the change in y is given by this equation in this model, where only the change in government spending is equal to 0, because here only government spending is fixed. This brings me towards the end of my lecture. Please feel free to email me if you have questions. Thank you.